Okay, so we're going to be using this application to do a little bit of investigating of something called the distributive property. And we're going to start with just looking at the problem of 6 times 13. Okay, so if you were doing 6 times 13, you'd probably write it out like something like this, and you'd break it down. 3 times 6 is 18, carry the 1, 1 times 6 is 6 plus the 1 that you carried, and you'd get 78. But let's break it down into perhaps a different way. So we could be using some number tiles to represent 6 times 13. And when I think about 6 times 13, okay, I'm actually thinking about 6. Oh, sorry. I'm going to think about a 10 and then 3 ones. That represents my 13. And if I have 7 or 6 of them, what I'm going to do is I'm going to copy that. I'm going to copy it 6 times. So I just highlight and copy one more time. Okay, so now I can look at this sort of in a more concrete fashion where I can see my 6 groups here and my 10 here and my 3 here. 6 times 10 is 60. 6 times 3 is 18. So together, this is going to be 78. I can also look at this in an area model, right? Because this is essentially the area of a rectangle, and it's 2 rectangles put together. So I can think about it in terms of area if I want to as well. Okay, so now what I'm going to do is let's look at a different problem. So let's look at 21 times 14. So again, if I were doing that in sort of the abstract way, I might write it out like this. I'd say 4 times 1 is 4, 2 times 4 is 8. I'm going to put my placeholder there. 1 times 1 is 1, 1 times 2 is 2, and then I'd add everything up, okay? And I'd get 294. If I wanted to break this down into a more concrete way, I might think of this as my 21 as being 2 groups of 10 plus my 1. Okay, so I'm just going to write that. There's my 10, and my 1. I might think of my 14 as a 10 and 4 ones. And I'm just, the last one's cut off a bit, so I'm just going to move that screen a little bit. Okay, and so now here is my 10 and my 4 there. Okay, now I can see my area model of a 10 by 10, a 10 by 10, and I didn't draw that well. That's okay. A 10 by 4, a 10 by 4, a 1 by 10, and a 1 by 4. So now I have a series of sections that are area sections. So my 10 by 10 actually ends up here. My other 10 by 10 ends up there. My 1 by 10 would be here. And I'm going to have a series of 4 groups of 10. So I'm going to copy that. And I'm going to highlight those 2 and copy that. And that gets repeated. And then I have 4 little ones here. So now if I wanted to think about this in an area model, I have a group of 100 here, a group of 100 here, a group of 10. 4 times 10, that's 40. 4 times 10 is 40. And then I have my 4. And so I end up with 100, 100, 40, 40, and 4. Oh, and the 10. I forgot about the 10. So I still get 294. But I've broken the numbers down into perhaps a way that I might be able to do quickly in my head mentally. So when I'm thinking about 21 times 14, I can do it this way. It's actually much easier for me to think of it as groups of breaking down the numbers. So breaking down the 21 into 10, 10, 1, and breaking down the 14 into 10 and 4. You might also have thought about it of like 20 and 1. and done 20 times 10. And that might have been a little bit faster. So why are we talking about these things? Well, we're talking about these things because what happens when we move into a more abstract way of thinking, like instead of having numbers, we have letters. So for example, what happens if we have 3 times x plus 4? What might that look like? So for this one, we're going to go to the algebra section and go to algebra tiles. So x plus 4, okay, that's just x tile and 4 single tiles. So what I've represented here on the screen is x plus 4. Now, I have 3 of those. All I'm doing is copying that 3 times. So this is my 3 right here. Here is my x, and here is my 4. Very similar to what I just did with numbers. Well, what happens? I end up with x, 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 or 3x, and I end up with 12. So 3x plus 4 becomes 3x plus 12. Again, I can think of this in terms of an area model. Okay, here's my 3 times x. Here's my 3 times 4. So this one is 3 times 4, and this one is 3 times x. So when I'm looking at that, if I want to think more abstractly, all I'm really doing is multiplying the 3 times x, and I just get 3x. I don't know what x is at the moment, so that I leave it at that, and I multiply 3 times 4. And my answer, that's my final answer, 3x plus 12. And that is called the distributive property. So let's look at one. What happens when, for example, you might end up with, it's going to let me, okay, so I want you to try one on your own. 7x minus 3. So you can pause the video and set it up on your own and give it a try. So if you're having trouble, or maybe you've already tried it and you want to check if you're right, let's first show the x minus 3. So there's our x, and we have to go to the negative tiles to get minus 3. There is my x and my minus 3. So now I need 7 of those. I'm just going to highlight. I'm going to copy. Then I can do a double copy. Just goes a little bit faster. And I can copy 3 more. And now I have 7 of those. So again, I think of this as area. 7 groups of x, that's 7x. 7 groups of negative 3, that's like 7 times negative 3, that's negative 21. So again, if I'm thinking about this more abstractly, 7 times x is 7x. 7 times negative 3 is negative 21. So all I'm doing is breaking this down, just like I did when I was looking at 6 times 13. Right? When I was looking at 6 times 13, what did I really do? I was really looking at 6 times 10 plus 3. And I did 6 times 10, which was 60. And I did 6 times 3, which was 18. It was a different way of looking at 6 times 13. Breaking it down into easier numbers, this with algebra is exactly the same. And as I said, it's called the distributive property. So what happens when we have, a negative? So for example, negative 3 times x plus 2. Okay, so pause it, try it on your own, or if you're unsure, just keep watching. So start, you get your x and your plus 2. Now, a little bit harder to think in terms of negative 3 times that. So negative 3 times x, what's actually going to happen, and I'm actually going to show this in a different way. So I'm going to put my negative 3 there. I'm going to almost make this into a little bit of a multiplication table right here. So when you think about this, negative 1 times x, you're actually going to end up with negative x, right? You're going to end up with the opposite. Negative 1 times 1, you're going to end up with negative 1. So whenever you multiply by a negative, right, you get the opposite. So I'm going to copy that. So what happens here is this part is negative 3x, and this part would be negative 3 times 2, which is negative 6. So when I look at it in a more abstract way, if I'm distributing, negative 3 times x is negative 3x, negative 3 times 2, be careful, even though that sign says plus, when I multiply by a negative, I get a negative. So we're going to look at one more, just to kind of get you thinking a little bit. And that one is, what happens if you had x times x plus 3? So again, you can set it up with the tiles, x plus 3. You can pause the video at any time and try it on your own and restart. And then we're multiplied by x. And again, I'm going to turn this into like a little times table chart. Oops, that did not go where I wanted it to go. Let's see if I can move it. Yep. Okay. So when I'm multiplying x times x, think about what that might be, right? Like 5 times 5. Yes, 5 times 5 is 25. But what's another way of saying 5 times 5 in terms of like a mathematical way of saying it? Or 3 times 3, 3 times 3 is 9. But what's another way of saying 3 times 3? So 5 times 5, another way of saying that is 5 squared. 3 times 3, that's 3 squared. So x times x is going to be x squared. Now, x times 1, you're going to end up with x, and you're going to repeat that 3 times. So again, if we think of this in an area model, this one represents x times x, which is x squared. This one represents x times 3, which is 3x. So my answer is actually going to be x squared plus 3x. And if I use the distributive property, x times x is x squared. X times 3 is 3x. So just something to think about. So this is called the distributive property. There is another video if you want to watch a little bit more of a summary of the distributive property, but this was the investigation. Play around with it a little bit. You can try using this application if you want to do some more exploring with the virtual algebra tiles. And hopefully this makes a little bit more sense to you in terms of using the distributive property.